Hello everyone, welcome to my YouTube channel. So I wish you all the viewers of this YouTube channel a very happy new year, and we are starting a brand new series on LLM. And in this new year, the first thing which I wanted to talk about is the most talked about model from 2023, the Mistral and the Mixtral, right? So I wanted to take you through the core architecture of this two models. So without further delay, let's get started. So this is kind of an introduction video where I will take you through like what are the things that we will discuss in this new playlist and how we are structuring this new playlist, right? So before going into the architecture of this whole Mistral 7B or the Mixtral 8x7B model, I wanted to take you through the what are the things that we will talk about in this series. Right. So first we will start with the very basic of self-attention. Then, using the concept of self-attention, we will try to understand what is sliding window attention. Then we will talk about rotary positional encoding. So this rotary positional encoding is kind of the thing which we could have started at first, but before that I wanted to talk about what is self-attention and sliding window attention, and with that we will talk about this new rotary positional encoding concept. Right, after that we will talk about the grouped query attention. Then we will talk about what is KV cache. Then we will like taking the concept of KV cache, we will also talk about rolling buffer cache, what it is and how it function in case of Mistral. And then we will also talk about prefill and chunking, and then we will slowly move into the Mixtral, which is 8x7B, a mixture of experts model. So there we will talk about what is sparse mixture of experts are, and then we will talk about what is model sharding, right? So far this is the plan which I have, like these are the things I will discuss in this new playlist, and if I feel that I need to add few things to this concepts, I will add in this playlist, right? So with that, let's talk about what is the architecture of Mistral, right? So we know this architecture very well. This is kind of the attention mechanism which you have, like that this is comes from the attention is all you need from paper. So we have like inputs are going in, then there is input embedding which converts the inputs to the embedding, and then we add a positional encoding, and then we have the encoder part, right? So encoder part we have mainly three things. One is like multi-head attention, then there is add and norm, and then there is feed forward network, right? And this encoding side we kind of repeat multiple times, so that's why you see the NX. So NX is like it is used and stacked multiple times on top of each other. And then we have this decoder part where we have like outputs are also gets passed through the output embeddings, then it gets added to the positional encoding, and we have this masked multi-head attention, right? So we will talk about in the next video what this masked multi-head attention along with the concept of multi-head attention, right? So then we have this regular stuff like multi-head attention, add and norm, feed forward network. Then in the end we have the linear layer and also the softmax layer, which tells you what is the probability of the next output token, right? So in case of Mixtral or the Mistral, what we have is this architecture. So this does not have any the paper which talks about the Mistral does not have any architecture. So this I kind of draw it by my own self. So what we have is, we generally this type of architecture we call it as a decoder only architecture. We have the input goes through the embedding layer, then we have the RMS norm. So we will also talk about this, what is this RMS norm and how it is different from the regular add and norm which comes into the attention is all you need paper, right? Then we have this rotary positional embedding. So this rotary positional encoding is only applied to the query and key component of the attention mechanism, and the value we do not add this rotary positional encoding. So then we have this block where we have like few of the concepts which you need to know, which is like SWA is a sliding window attention, then there is grouped query attention, and rolling buffer KV cache that also is applied in this section. And then again we have a normalization RMS normalization layer. Then we have the feed forward network. So in this feed forward network, the concept of a mixture of expert comes into the play. So we will also look into the future videos what is actually it is doing. Then we again have the RMS norm layer, and in the end we have the regular linear layer and the softmax layer, which will give you the probability distribution of the next probable output token, right? So this is kind of a high level architecture of the Mistral, and this is what I wanted to start with. uh, and in the next few videos I will talk about each of this component in detail, and I will try to explain each of this component with like visualization, uh, and also the detailed explanation of each of these components, right? So I hope you got an initial understanding of what this series would look like, and I hope you are also excited to learn this new concept with this new series. So yeah, so if you haven't subscribed this channel, please subscribe, and also like and share this new playlist which I am coming up with your friends and colleagues, which will help this YouTube channel to grow. Okay, so in the next video I will talk about the self attention mechanism, and slowly we will try to go into uh, the sliding window attention with the help of self attention concept. Thank you. See you in the next video of this series.